Alright everyone, welcome back to the day 38 of our daily leetcode challenge, and today we have got find the number of distinct colors among the balls. So in this question what they have provided us is with an array called queries and a variable called limit. The limit here indicates that they have provided us with a limit plus 1 balls. The reason why doing a limit plus 1 is because the balls will go from 0 up till 4 inclusive, so that is why limit plus 1 balls in total. Since the value of limit is 4, so we'll have balls like 0, 1, 2, 3, 4, so that is why limit plus 1, 5 balls in total. So this is how the limit is defined, and in the queries it indicates that the ith the all I and j pairs in queries, it indicates that the ith ball is colored with the jth color. So in this case it would mean the ball I is colored with color 4, the ball 2 is colored with 5, ball 1 is colored with 3, and ball 3 is colored with 4. And what we need to do is we need to return an resultant array called result, in which we need to store for after each query we need to find what is the current number of distinct colors the moment we perform query. Let's say ith query we perform, what is the number of distinct colors. So in this case we'll try to do a dry run quickly on the first example and see how we are getting 1, 2, 2, 3. So here all these colors are codes here. So what I have done is I have taken 5 colors from paint and I have coded them as 1, 2, 3, 4, 5, as you can see here. So this would mean that the color 4 is indicated by yellow, the color 5 is indicated by green, the color 3 is indicated by orange, the color 4 is again indicated by yellow. We're going to use these colors for a better visual representation of the question. So let's try to do a dry run on example 1. So on running the query 0, which is 1 comma 4, indicates that we need to color the ball 1 with the color 4. The color 4 is yellow, so I am coloring ball 1 with color 4. The moment we do that, what is the total number of distinct, you can think the number of distinct colors so far in this entire resultant. You can see all the balls that we have so far. What is the number of distinct colors that we have, which is 1. Since yellow is the only color, so 1. So now 1 we have. Now let's move forward. We are painting the ball 2 with color 5. The color 5 here is green, so you'll have to paint color ball 2 with 5, which is green here. So we did that, and the moment we do that, we see that now the number of distinct colors is 2. So we'll have to append 2 in the list now. So this is 2 now. Let's move forward. We are now on the third query, which is 1 comma 3. This means that I need to color ball 1 with the color 3, which is orange. So I'll have to color ball 1 with 3, and I do that. So we find again the number of distinct colors so far is 2 still, so which is orange and green. So I'm gonna put 2 again in the list. Then we move forward, then we come on to the fourth query and the last query, which is 3 comma 4. So 3 comma 4 indicates that I need to color the ball 3 with color 4. The color 4 is yellow here, so I do that, and we see that now the moment I perform the last query, I am getting 3 unique colors now. 3 unique colors, which are orange, green and yellow. So that is why I am appending 3 now. So this is what we return. 1, 2, 2, 3. This is what is happening. Let's try to do the same thing on the example 2, where again the limit value is 4, meaning they have got 5 balls in total, and queries value is 1, 2, 3, 4, 5, meaning we have to do 5 color operations. Let's try to do that one by one and see how we are getting the answer 1, 2, 2, 3, 4. Let's see that. So again, let's start with the at the 0th query, which is 0 comma 1. This indicates that we need to color the ball 0 with color 1, which is maroon in this case. So I'm coloring ball 0 with color ball 0 here with color 1. So I'm appending maroon here. This is done. Now the query, which is 1 comma 2, indicates that I need to color ball 1 with color 2. The color 2 is red right now, and again with each iteration we'll have to again maintain a count of number of distinct colors we found so far. So if in the case of the second example, you see the first query that we performed, we colored the ball 0 with color 1, which is maroon. We did that. The moment we do that, what is the number of unique colors that we have, which is 1 just. So we'll have to add 1 in our resultant array. That is done. We move to the next query, which is 1 comma 2. This means that we need to color the ball 1 with color 2. Here color 2 is red, so I'm painting ball 1 with color 2. The moment I do that, what is the number of distinct colors that we have, which is 2. So I'll have to add 2 in the hash in our resultant array now. So this is 2 now. On performing the third query, which is 2 comma 2, this indicates that I need to color ball 2 with color 2, which is red. So I need to paint ball 2 with color 2, which is red. I do that. our number of distinct colors will still gonna be 2, which is maroon and red. So I'm gonna have to again append 2 back in our resultant array. Moving forward, we have got 3 comma 4. This indicates that I need to color the ball 3 with color 4. The color 4 is yellow, so I do that, and the moment I do that, it becomes 3 now, the number of distinct colors. So I'll have to append a 3 in the array now, which is 3. I appended just that, 3 distinct colors at the moment. The moment we perform the color, our distinct colors are 3, so we put that. On the last iteration, on the last query, we have to paint ball 4 with color 5, which is green. So if I do that, the ball 4 gets painted to green. Now the number of distinct colors is 1, these 2 red, 1 yellow and 1 green. So this is 4 in total. So that is why we are getting a 1, 2, 2, 3, 4 in the final array. So if you see, this is how the iteration is working. We just did a dry run. Now what I want you to do is imagine this entire color set that we imagined. Like let's say that we have already been provided, these are the colors that we know. So what if after each iteration we prepare a hash map to get a count of which color is getting appeared to how many times. So in this case we saw that these were the 5 colors we used, right? Let's try to do one thing. Let's try to create this as a hash map. We'll remember which color is what by the index of it. Like we clearly know this is the first color, this is the second color, but this time we'll just create count a kind of maintain a count of which color appeared what time after each iteration. Because if you think about it, this is what we are doing. We are kind of counting which color appeared what time it appeared. It doesn't matter. What it does matter is how many colors are actually appearing at a time. Initially all of them will be 0, since we know these are the colors they are using. But after each iteration we can kind of see that alright, this color is appearing 1 time, this color is appearing 2 times, but it is appearing at least. So that is what we are doing. So let's try to do the same thing, but this time what we are doing is we are trying to create a hash map where each color is initially assigned to 0, right? And we'll kind of after each iteration, after performing each query, we'll kind of maintain a count of the color appearing what time, and accordingly we'll append this array that we have. So if we do that, I'm going to start again from the beginning, and all the cells are uncolored. So let's try to do the same coloring part again. So on the first example, if you see, we perform query 0, which is 1 comma 4, coloring ball 1 with the color 4. So the color 4 is 1, 2, 3, 4, which is yellow. So I'm performing color query 1 with 4. So this gets colored to yellow, and this gets updated to 1. This gets updated to 1. From this 0 will get updated to 1, since 1 is appearing, yellow is appearing 1 time, right? So again in this hash map, if you see, the colors that are actually appearing, no matter which are actually greater than 0, that's what the count we need. It's just 1. This yellow is appearing once, so we have 1 in the answer set. Now let's perform the second query, which is we need to color ball 2 with color 5, which is the last one, green. So I'm coloring ball 2 with the color 5, which is green, and now I need to update this green to 1. Now if I ask you what is in this hash map, what are the colors that are actually appearing more than 0 times, like greater than 0, which is 2. So this gets updated to 2. Now we need to perform the same. Now what we need to do is we need to perform the coloring of ball 1 to 3. Now you have to kind of notice something. The moment we color ball 1 with 3, we saw that this was already colored, right? Since we can see it here, it was already colored to yellow, and now we are coloring it to 3, which is orange in this case. We are kind of diminishing, like we are removing this yellow, or basically setting its count back to 0, and then increasing the count of orange to 1. That is why even after doing this, like since we are decoloring yellow and coloring orange here, so we are kind of reducing this count of yellow from 1 to 0 and increasing this count of orange from 0 to 1. That is why even though we are reducing this 1 from 0 and increasing the 0 to 1, the count or the number of colors that are greater than 0 is still 2. That is why the moment we colored this ball 1 to a orange, which is this, the moment we do that, what we are doing is initially it was colored to a yellow, and then we colored it to a 2, which we colored it to a color 3, which is orange. So what we are actually doing is reducing this from 1 to a 0 and increasing this from 0 to a 1. After doing so, we found that the colors that are greater than 0 is still 2, which basically means the number of distinct colors after performing that. So that is why it's still 2. Now moving forward, we get 3 comma 4. So we are coloring 3 with the color 4, which is 1, 2, 3, 4. yellow color. So performing this 3 to a 4, which is like coloring it to yellow, and this count again becomes 1. It diminished to 0, but now it will be back to 1. So this becomes 1 now. So now if you see all the colors so far in which are greater than, you can say 1, greater than 0, or it means that these are the distinct colors so far. These are the distinct colors so far. Why so? Because they are not 0. It means they have been used, you can say. They have been used somewhere. It doesn't matter how many times they are used, but they are used. So this means that so far the colors yellow, the color orange and the color green are used. This means 3 so far. So we put a 3 here. This is why we get 3, 1, 2, 2, 3, and this was our last query that we performed. Let's try to do the same thing on the other example, the second example, but using this again, the hash map concept that we used. So I'm going to put all this to set back all these colors to 0, because this is how it is going to be like in the beginning. All these will be 0, and with each coloring we're going to update the count so that we know what is the distinct value. So all of them are 0 initially. For the second example we are doing now, all of them are 0. Now in the second example we have to color the, and this will be our resultant array. We store the distinct count of colors appearing in this one. So we have the limit 4, 5 balls here, and these are the queries. So we have to update, we have to kind of paint the ball 0 with color 1. The color 1 is maroon. So now we have to update this to 1 and paint our ball 0 to a maroon. So this gets painted to maroon. Now we need to check what is the current count, or we can say the distinct colors so far. So distinct colors are the colors which are getting used right now. The only color which is being used right now is maroon. So we need to add 1 now in the list. So this gets added, this is 1 now. Moving forward, we painted the ball 1 with the color 2. So the color 2 is red. So this is getting used, this gets updated to a 1, and we have to update the ball 1 with color 2, which is red. So let me quickly do that. This gets colored to red. So far, if you see which colors are getting used, the colors maroon and red are getting used, which is the count is 2. So we need to add 2 now. So this gets 2. Now moving forward, we have to color the ball 2 with 2, which is red again. So this gets updated 2 now, because red is again getting used, and this ball 2 gets painted to a red. And the number of colors being used are still maroon and red. So this will still be 2 on our third iteration. And moving on the fourth iteration, we need to color the ball 3 with color 4, which is yellow. So yellow gets used once. So this gets updated to 1. And we need to color the ball 3 with yellow. So this gets colored to yellow. Now if you see, the colors getting used are maroon, red and yellow. So 3 in total. So we add 3. We add 3 to our answer. So this becomes 1, 2, 2, 3. Now we come to 4, which is the last iteration. We have to color the ball 4 with 5, which is green. So this green gets used. This gets updated to 1. And I have to paint the ball 4 with the color 4, which is the color 5, which is green. So I do that. Now the number of colors getting used are 1, 2, 3, 4. No matter what the kind of count is, it's just that which color is getting used. If it's greater than 0, we just have to add that. And the number of such colors is 1, 2, 3, 4. 1, 2 here, 3, 4 here. Orange is not used anywhere in this iteration, so we add 4 here. So that is why we are getting a 1, 2, 2, 3, 4. So this is how we can kind of use this color map to know that which color is getting used. It doesn't matter how many times is used. We can use a color map to find, alright, this is the at a particular, after performing a colorization, we can see that alright, these are the values in the hash map which are greater than 0, or the values in the hash map which are currently there. So we can add that length of that hash map to the answer list. We will be starting with an empty color set initially, so and then after each coloring we'll add that color and its count. I gave this just an example. We'll starting with an empty color map, but if you saw in the previous example, we had to kind of, when a previously colored cell was getting colored, we had to reduce its count by 1. But how will we get to know if a previously colored cell was colored? Like how will we know that this cell was previously colored and not colored? Like how will we know that? So for that we'll need another hash map for the balls. This is the hash map for the colors, and this other hash map will be for the balls. Like this will indicate that ball 0 is getting mapped to which color. When that happens, and if we let's say that, like in this case, in the previous one, if you see the ball 1 was colored, in this case the ball 1 is getting colored firstly with 4, so we'll update 1 with a 4, and then later down the line we saw that ball 1 is again getting colored by a 3. So in that case, we'll have to kind of reduce this 4 in the hash map that we have, which is 1, 2, 3, 4. Its count will be getting reduced to a -1, and if it gets 0, we'll again pop this out from the hash map, so that we can kind of get a count of the number of colors that are actually getting used dynamically. So this is how our two hash map is going to be used. First hash map will be to find the this will be the ball map, the other one will be the color map. The ball map which indicates which ball is mapped to which color, and the other one will be the second hash map will be to like which color is getting used how many times. And if let's say 1 was originally mapped to color 4, then again we saw that 1 is getting mapped to 3. This means that this value 1 is getting repainted. So we need to kind of remove this color from this one, they kind of reduce its count from 1 to a 0. So that is why we're gonna use two hash maps. So let's try to code this now. Alright everyone, so let's try to code everything we discussed so far. So as we discussed, we're gonna need two hash map. One will be the ball map and the other will be the color map. The reason we are using two hash map is because if you take a look at the first example, when we are at this query, we are painting ball 1 with ball 4. So what we're going to do is in the ball map, 1 will be getting at 1 will be set to 4 and the frequency of 4 will be set to 1, right? But when we come to this one right here, which is 1, 3, we'll see that whatever color ball 1 is attached to, which is 4 right now, is already there in the hash map. And now what we are doing is setting this ball from 1 to 4 to 1 to 3. This is getting reduced, getting set from 1 to 4 to 1 to 3. So what we are doing is we are reducing the count of 4 which appeared so far by a 1. So that is why this will be set to whatever values which we have so far -1. This will become 0 because this is why 4 got lost initially but later came back via 3. So what we are doing is we are kind of updating the values in this color map dynamically. When it gets to 0, we'll have to pop this so that later when it's added, we always get the correct kind of the snapshot of the hash map what we are currently at with each iteration. So that is why we are using two hash maps, ball map and color map. This ball map right here will help us know if we are repainting a cell. How will we know that if we are repainting a cell? Because 1 is already colored to 4 and 4 gets updated to 1 on the first query. Then 2 gets painted to 4, then our hash map will look something like this. 2 gets painted to 5 and 5 appears one time, so this is fine. Then will come 1, 3. We see that the ball map, in this ball map 1 is actually painted to a 4. So before we paint to a 3, this 4 needs to be reduced to a -1, which will become 0, and the moment it becomes 0, we need to pop this from our hash map. So this will be gone, and then we'll again repaint 1, 2, 3. So this will get updated to 3, and here we'll have our 3 count to 1. That is why the moment we reach this one, if you take a look at the snapshot of the hash map, it looks the length of this hash map is 2. That is why we are updating 2 here, and later again we see 3, 4 coming in. So in the ball map we set 3, 4, 3 gets mapped to color 4 and 4's count get updated back to 1. It was 0, so we popped it. The reason we are popping it because so that we are only going to bother about colors that are getting used, and by used meaning they have a frequency of 1 or more than that. That is why we are popping that value, and we are using two different hash maps. So this is how the logic of two different hash map is coming up. One is for the mapping which ball is colored to which color, and the other one is to just get a snapshot of which colors are getting used at the moment. After reperforming each query, we are going to append the length of that particular hash map in the resultant array that we have defined here. So let's start iterating for each query for I, j in queries. Alright, so now comes the part where we need to see if a particular ball is getting repainted or is already being mapped to a particular color before. So in this case you see 1, 3, the moment we reach 1, 3, we see that 1 has already been colored to 4. So you have to reduce that count in the color map. How will we know that? This gives us a color, right? Ball map I. If this color is already in the color map, we will have to do a dot get so that it doesn't give us an error initially. If this color is in the hash map, ball map dot get for this ball right here that we reached here I, this ball whatever color we are getting is already there in the hash map. We'll have to reduce this particular color that we are getting, its frequency in the color map, by 1. This is what we are doing right here. So this color map, so if this is true, this if condition is true, what we need to do is in this color map, this ball map color that we are getting is getting reduced by 1, and if its value becomes 0, which we saw, this 4 will eventually turn to 0. We'll have to pop this from our color map. We have to pop this value from the color map. Right, so this is the part where we are kind of removing that color from the color map. If it's already being used, like 4 was already used and then it is getting repainted, how did we know? We checked basically. So in this ball map, is this one that we have they are getting here, is it already mapped to a color? Yes, it is mapped to a color, which is 4. So you need to reduce this 4 by bit frequency by 1. So this is nothing but a color value we are reducing by 1, and if it's 0, then we need to pop it from the color map, and this is where the popping is appearing. And if that is done, then what we need to do is simply map this ball to this color, which is I to j, and which color is getting used gets updated in the color map, basically the frequency. And once that is done, in our resultant array that we have provided, we need to append whatever the current snapshot of this color map is, meaning the length of this hash map, or the length of the color map, or basically the number of colors which are actually getting used. And in the end, we just need to return this resultant array. So as you can see, it's running all the test cases. And now if you try to submit this, it's satisfying all the test cases. So that was it for today, everyone. I'll see you in the next one.